So now let's look at graphs of functions. And this will give you a good visual representation of what functions are doing. Think of it as, when we're going through these, think of it as one input, one output. Think of it as you're at the grocery store and you scan two of the same item. So 2 milks, you scan them both, and then they both should come up as the same price. They both should be $2 each. You shouldn't scan one milk and it be $2, and then your second milk be $10. Something's wrong, and you would throw a fit at Target, and you'd get the price back down to what it should be. Think about that while we're going through this. There's only one input for one output, one x value, and for every x value there's exactly one y value. For one milk, there's one output. For every single item at the grocery store, there should be one output or one specific barcode. So let's say example 1. Determine. Let's say draw a graph of a function. All right. So let's just draw one together. See where we wind up. Here's the x-axis and the y-axis. And now I want to start putting points on this, and I want to start connecting the dots, drawing my graph. I have to keep in mind I want this to be a function. I want every x value to have exactly one y value. So let's start with an easy one. Let's say we have a point here at 0, 0. All right. So now I've already said my x value of 0 has a y value of 0. Now that means, if I'm drawing a function, that means I cannot use any other y value that has an x value of 0. So this is my only dot, my only point I can have on this entire y-axis, because x value is 0 anywhere along here, it's 0 along here. So if I were to put a point down here, then this instantly would make it not a function. So let's not do that. We need to keep that in mind. Once I make a point, once I make an x value, and I give it a y value, I can no longer use that x value anymore. So if I'm here at 1, 1, and I draw another point, that means I just use the x value of 1, and I can't use any other points on that x equal 1 line. So I can no longer draw a point up here at 7 if I needed one. All right? So now 2, and let's give it a y value of 2. Now that means I can no longer use any other values along that x equal 2 line, and so on. Now let's go the other direction. I can go x value of -1, and I can give it a value of, well, I can give it any value I want right now because none of them were used. So I could give it 100 up here, I could give it -1,000,000, I could give it -1. So I'm just going to use -1 and -1 for now to make it easier. And then let's go to -2. I can use any y value on -2 right now until I put that value there. So let's say I use 7. And it's not to scale, but you get the idea. So if I connect the dots, I get a graph like this, and it kind of rounds here, not a point. But so this would be a function, and there are infinitely many of these. You try to draw one yourself. And I'm going to call this one part A, call this part B. All right, try to draw one yourself, but I'm going to continue on and pause the video if you need. Here's the x-axis and the y-axis. All right. So over here, let's say at x equals 0, I have a point here at -3. So my x value of 0 has a y value of -3. I can no longer use any more x values. Now let's say let's say my x equal 1 has a value of x equals 1 and a y value of 0, so it's right there on that line. And then let's say negative 1 has a y value of 0. And is that legal? Is that still a function? Yes, it is. Don't let what y values we're using throw you off. It matters if what x we're using, if each x has if every x has exactly one y value. So this x value of 1 has only one y value. It's 0, and that's good. That's what we want. Same thing here. This x equal negative 1 has one y value, and it's 0 also. And I said that wrong, I think. This x equal 1 has a value of 0. So when you draw the dot here, you need to make sure that there are no other just look vertically, there are no other, that x value doesn't have any other y values on that line. So if I want to come out here to negative 2 and say it has this value of 5, and if I want to come over here to positive 2 and say it has this value of 5, that's okay. As long as this x value of negative 2 only has one y value, and it does, of 5. And as long as this x value only has one y value of 5, then we're good. And then roughly connecting the dots, you get something like that. All right, so it's all about looking vertically. Does this x value only have one y value? Yes, it only uses this point right here. You just keep looking vertically like that. Let's look at one more. And let's draw one that's not a function. Example 2. Draw a graph that is not a function. Call this part A, x-axis, y-axis. All right, so let's just pick a point here. We'll call it 0, 0 as our first point. And then let's get 1, 1 as another point. You know what, let's just keep going. Let's pick another x, let's say 2, and we'll give it the value of 2. All right, and then we can keep going if we want. But let's say that's our graph. If I just left my graph, just like this, if I just left it, this is a function. Because every x value has one y value. Here at x equals 0, it only has this y value of 0. Here at x equals 1, it only has this y value of 1. Here at x equals 2, it only has this y value of 2. So now let's make this not a function, just by extending the graph. So to make it not a function, that means I would need to just pick one of these x values and give it another y value. So here at x equals 1, I already have 1. Now let's give it another value here of y equals negative 1. And so by doing that, now I've created this x equals 2 now has two values also here. So if you look vertically, now this x equals 1, where before it only had this y value here, but now I've given it 2. So now it violates this vertical rule here. It has two values. If you draw a vertical line now through this graph, it crosses twice, whereas before, if we were to draw a vertical line on the previous example, it would only cross the graph once. And that leads us to something called the VLT, the vertical line test. And it comes in handy with looking at graphs. It's a quick and easy way to the vertical line test. Also known as the VLT. So when I write it from now on, I'm going to say VLT. All right, it says to, when you draw a vertical line down your graph, it should touch the graph at only one spot. If it doesn't, then it's not a function. All right, let's look at an example of this. Actually, I'm going to write it down first of what I'm saying. If, let's use white so it kind of stands out. If any vertical line drawn crosses the graph in more than one place, it's not a function. All right, so I just give you a graph that looks just like this, and you take your pen, or don't use a pen, please, use a pencil. But you take your pencil and you draw a vertical line like that, and you can see it crosses the graph here and here. All right, and it only has to do that in one spot, not every spot like I drew here. So just be aware of that.